Stanford found the solution. The Electronic Research Lab worked on microwave power tubes and invented something and perfected something called the backward wave oscillator. Electronically tunable, all you should know was it was fast and very good, and the military loved it. The other thing that really happened was these electronic intelligence receivers needed the same solution. They needed to be very wide and very fast. They needed to cover an entire frequency spectrum, and they needed to jump quickly. Again, the solution was something that Stanford perfected called the traveling wave tube. These two tubes, while interesting to maybe not this audience, but they were very interesting to the military. But here was the key idea. In Terman's lab, while these devices were being developed in the 1940s and 50s, a bunch of engineers and professors said, hey, I know how to make these. Thanks a lot, Fred, for teaching me how to do this stuff. I'd like to leave Stanford and start companies. And you know what Terman said? Congratulations. Here's the IP. Have a great time. Help defend our country and start a company. Big idea. Stanford spin-outs started Silicon Valley in mass quantities in the 40s and 50s in microwaves for the defense industry. Because the Cold War was turning Silicon Valley, way before it was Silicon Valley, into a black valley. The Cold War battlefield had moved 500 miles east to the Soviet Union. There was a serious fear of a nuclear Pearl Harbor, and because the Soviet Union was a closed country, unlike Germany, we could not fly over it without starting a war. So being able to see into it was really important, and being able to provide our bombers with defenses was very important. Stanford became a center of excellence for not only the Army, the Air Force, and the Navy, but for the CIA and the National Security Agency, starting in the late 40s all the way up to 1969. Stanford joined the black or spook world in the mid-1950s when the unclassified lab got put together with a classified military programs lab in the engineering department and made Stanford University for the first time a full partner in the whole military-industrial complex. These labs merged the same year Terman became provost, and Stanford, by the end, had a full-time 800-person military weapons lab by the mid-1960s, making these devices for the U.S. military and other agencies. Their problem was basically to help these agencies understand the Soviet Union's radar order of battle. Where are the Soviet radars? What are the details of the radars? The periphery of the Soviet Union was known, but the inside of the country wasn't known. And Stanford did a lot of interesting work here. I want to give you one good example. One of the problems was understanding where the Soviet Union's air defense radars were. Some of them were on the outside of the country. We could see those electronically. But we had no idea where the ones in the middle were. This was the primary Soviet air defense radar. The B-52 bombers, if we were ever going to have to attack the Soviet Union, would need to know. Some of our spy planes would need to know. And we decided the way to find out was by an accidental discovery made 5 years earlier. It turned out that some scientists at Bell Labs at New Jersey had pointed big radio receivers at the moon to see if they could bounce some signals off, see how far we could make radar work. And then one day, when they weren't sending any radar signals themselves, they still had the receiver on. And they started seeing signals from the moon. Oh, let's play spooky music here. Well, we're getting radar signals from the moon. Well, maybe there were moon men and whatever. But they noticed that the radar signals from the moon would only come when the moon was kind of aligned with the Soviet Union. Well, that's kind of interesting. And then they called some of their military friends and said, did you know we could? And they went, we could what? What they discovered is if you built a big enough radar receiver and did the right geometry about an hour a month, when the moon and Russia and the United States was all aligned, you could actually not only pick up these Soviet air defense radars, but you could geolocate them, figure out exactly where they were. Except we didn't have big dishes in the late 1950s. All of a sudden, the United States became the most interested country in the world in radio astronomy. Late 1950s, the U.S. funded Sugar Grove, Arecibo, Jordal Bank, and the Stanford dish. Stanford dish was funded by the National Security Agency to pick up Soviet Tolkien and then later in-house radars. And how it worked is no one knew where the money came from. DARPA was just a huge, big fan of funding radio astronomy, but 1 hour a month, these guys came in and used this closed room in the corner. And the astronomers were happy. Hey, they're paying for it. They get their hour a month. We stopped using this in the mid-60s when we had enough electronic intelligence satellites, gave it back to the astronomers that had no idea what was going on. And if they did, this was the first policy of don't ask, don't tell. Stanford spin-outs not only built microwave components, but they built complete military systems starting in the mid-50s. Sylvania, GE microwaves, etc. One of the most interesting ones, ESL, Bill Perry, who became Secretary of Defense, teaches in the Stanford MS&D department, was the founder of Ergo Systems, Advent, etc. Terman, as I said earlier, changed the startup university rules. Silicon Valley, as we knew it, started with this one professor whose goal was to defend the United States in the Cold War. He did everything he thought was right for his country. Explicitly, what happened here was that graduate students were encouraged to start companies. Professors were encouraged to consult for companies. Terman and other professors took board seats. This guy was on the board of HP and Varian and Watkins Johnson, etc. And he encouraged all his other professors to do that. And more importantly, technology transfer and IP, this is even before the OTL office here, was a handshake. You want it? Take it. Make sure it was good for our country. Getting out in the real world here at Stanford in the 1950s was as heretical as you will get anywhere in the world. It was good for your academic career. Terman in the Cold War was Silicon Valley's first engine of entrepreneurship. Basically, the key idea is while there were entrepreneurs, there was no venture capital. How did these companies get funded? They had military customers from day one. They knew when they left Stanford, they were building devices that had customers. And most of them didn't directly contract to the military, they contracted to all the aerospace companies. Fairchild Semiconductor, same business. 1956 was another seminal year for Silicon Valley. A company came to town that had been around for a couple decades, but never in Silicon Valley, Lockheed. Lockheed came to town in 1956 to Sunnyvale to build a submarine-launched ballistic missile. Most of you don't know, but Sunnyvale is the home of nuclear missiles for the U.S. submarine force. Every generation of submarine ballistic missiles were built in Sunnyvale. Westinghouse, for those of you who remember, Westinghouse had a great, you could be sure it's Westinghouse, anybody ever hear that? Right? These guys actually built the missile launch tubes at Hunters Point in San Francisco. Westinghouse and Lockheed were the prime contractors for the military system. What's interesting is they went from 0 employees to 20,000 in 4 years. This is the company that populated Silicon Valley. Just for scale, when Lockheed had 20,000 employees, HP had 3,000. Now, the other thing that people don't know about Lockheed is they built most of the early spy satellites for the U.S. government, particularly for the CIA, here in Palo Alto. They built the first photo reconnaissance satellite on an assembly line on Willow Road in East Palo Alto. 145 of them. They were turning them out week after week. And if that wasn't enough, there was another assembly line for another secret space device, and that was something called the Agena. They built 365 of those. They were turning out one almost every week in Sunnyvale. 20,000 employees in 4 years. Lockheed and Stanford were still working together on spy satellites all the way to April 9th, 1969. By 1968, about a third of Stanford's electronic research funding was coming from the military. 50% of SRI's money was coming from the Defense Department. On April 9th, 1969, 400 students occupied the Applied Electronics Lab, and Stanford ended all its military contracting on campus. Stanford got out of the military business. Ended there.